Hello everyone. In this video, I have discussed the nomenclature of coordination compound using the IUPAC rules. If you find my videos helpful, then please like and subscribe to my channel and don't forget to click on the bell icon to get new video updates. Let's get started. The nomenclature, that is the systematic naming of coordination compound, is based on the rules recommended by the International Union of Pure and Applied Chemistry, also known as IUPAC. I have summarized the various IUPAC rules that must be followed while naming the coordination compound. Number 1. The cationic part of the coordination compound is named first, followed by the anionic part. There must be a space between the names of the cationic part and the anionic part. In the coordination sphere of this complex, we have 4 amine ligands along with the copper metal. This coordination sphere represents the cationic part, so tetraamine copper 2 is written first, as you can see in the next column. In the second complex, the coordination sphere represents the anionic part, so hexacyanoferrate is written after the naming of the potassium. Number 2. The ligands are always written before the central metal. There should be no space between the names of the ligand and the central metal. In this complex, we have 4 carbonyl ligand along with the nickel. So the name of the complex is written tetracarbonyl nickel. As you can see, there is no space between the central metal and ligand. Number 3. If the central metal is bound to more than one ligand, the names of the ligand are written in alphabetical order. The alphabetical order is not affected by the numerical prefix applied to the ligand. In this complex, we have 2 different ligands, chloride and ethylene. Thus, based on the alphabetical order, chloride will be written first, followed by ethylene. Number 4. The anionic ligand which end in "-ide" is replaced with an ending "-ido" or "-o". For example, bromide changed to bromido or bromo. Actually, in the old edition of IUPAC rules, the anionic ligand which end in "-ide" is replaced with an ending "-o". That is, bromide is named bromo. However, recently IUPAC revised it and changed it to "-ido". So you may find both types of suffix in literature. "-ite" is replaced with an ending "-ito". For example, nitrite changed to nitrito. "-ate" is replaced with an ending "-ato". For example, nitrate changed to nitrito. These are some examples of anionic monodentate ligand. Fluoride, chloride, bromide and iodide are named fluoro, chloro, bromo and iodo respectively. Hydroxide become hydroxo, while azide, amide and acetate are named azido, amido and acetato respectively. These are some examples of anionic bidentate ligand. They are also named according to suffix in their name. Oxide, peroxide and superoxide are named oxo, peroxo and superoxo respectively. Carbonate and imide as carbonato and imido, while sulfate, sulfide, thiosulfate and sulfide are named sulfato, sulfito, thiosulfato and sulfido respectively. Okay, number 5. The names of the cationic ligand end with "-ium" are written as such. For example, hydrogenium, nitronium and nitrosonium are named as such. Number 6. Except for the neutral ligand carry their normal name. These 4 ligands are ammonia, water, carbon monoxide and nitrogen monoxide, and they are named amine, aqua, carbonyl and nitrosyl respectively. Methylamine, pyridine, phosphine, triphenylphosphine and thiourea are written as such. These are a list of some commonly used polydentate ligands. Some of them are anionic, while some are neutral ligands. You can have a quick look at the other ligand, or you can also pause the video. I have tabulated the various examples of bidentate, tridentate, tetradentate, pentadentate as well as hexadentate ligand. Number 7. Some ligand can bind to central metal from two different sides, that is different atoms. These ligands are referred as ambidentate ligand. So in nomenclature, the point of attachment is indicated by mentioning the symbol of the atom in parenthesis or round bracket just after the name of the ligand. For example, cyanide ligand can bind the central metal through the carbon atom as well as through the nitrogen atom. If it is binding through carbon atom, then it is named as cyano-C-, and if it is binding through nitrogen atom, then it is named as cyano-N-. A similar rule is also considered while naming the other two ambidentate ligand like thiocyanato and nitrito as shown in this table. Number 8. If the same ligand is present more than once, the numerical prefix di, tri, tetra, etc. are used to indicate the number of same ligand. However, if the ligand already has a prefix like di, tri, etc., then prefix bis, tris, tetrakis are used. The alphabetical order is not affected by the numerical prefix applied to the ligand. Here I have tabulated the prefix used for monodentate ligand as well as polydentate ligand. Consider the example of chromium complex. Here we have two monodentate ligand, water and chloride. As there are two chloride ligand, we will write dichloro. Also, there are four water molecules, we will write tetraaqua. In the complex of cobalt, we have ethylene diamine, which is a polydentate ligand that itself contain a prefix, so we use prefix bis, bis ethylene diamine. Number 9. The oxidation state of central metal is indicated by a Roman numeral in parentheses or round brackets, and there should be no space between the name of metal and the parentheses. The oxidation state of iron in this complex is 3. As you can see, the Roman numeral 3 is written in round bracket just after the naming of iron. If the central metal form an anionic complex, its name ends in ate. Like cobalt becomes cobaltate, aluminium becomes aluminate. Similarly, chromate, vanadate, cuprate, nickelate, zincate, osmate, cadmate and platinate. Some metals are changed to their Latin names when part of an anion complex. For example, iron as ferrate, tin as stannate, lead as plumbate and silver as argentate. The IUPAC nomenclature of this complex of gold is dicyanoaurate. Gold changed to aurate. Number 11. A prefix mu is used while naming a bridging ligand, and such ligand are separated from the rest of the complex by using a hyphen. In this complex, hydroxide is a bridging ligand, so its IUPAC nomenclature is penta-aqua chromium 3 hyphen mu hyphen hydroxo hyphen penta-aqua chromium 3 space iron. Since both sides of the bridging ligand are the same, so we can also write the name of this complex as mu hyphen hydroxo hyphen bis in a bracket penta-aqua chromium 3 bracket close space iron. Number 12. The geometrical isomers are designated by the term cis or trans. In diamine dichloroplatinum 2 complex, two geometrical isomers are possible. If the same ligand are adjacent to each other, then the prefix cis is used, and if the same ligand are opposite to each other, then prefix trans is used. If the same ligand is present as bridging and as a non-bridging ligand, then the bridging ligand is named first. Optical isomers are designated by the symbol plus or small d and minus or small l to indicate dextrorotatory and levorotatory respectively. While writing the chemical formula of the coordination compounds, abbreviations are used for complex ligand. And the last one is the suffix ion is used with the name of the complex ion, and there is a space that have to be provided between the name of the complex and the ion. Naming of the coordination compounds. Consider the following example of cobalt. Here we have two ligands, amine and thiocyanate. Alphabetically, amine will come first, so tetraamine due to 4 amine ligands. Then dithiocyanate ligand. Since the thiocyanate ligand is bonded to cobalt through the sulfur atom, the capital S is added along with the hyphen mark. Amine is a neutral ligand while thiocyanate ligand carry a -1 charge. Therefore, the oxidation state of cobalt is +3 as the coordination sphere also carry a +1 charge. This is why 3, a Roman numeral, is added in a round bracket next to the metal name. Lastly, as the coordination sphere carry a charge, the suffix ion is added after leaving a space between the name of the complex and the ion. This complex is similar to the previous one. Here the thiocyanate ligand is bonded to cobalt through the nitrogen atom. So instead of capital S, capital N is added along with the hyphen mark. The rest is the same as the previous one. Consider the following example of chromium. Here we have two ligands, amine and nitrito. Alphabetically, amine will come first, so pentaamine, then nitrito. Since the nitrito ligand is bonded to chromium through the nitrogen atom, the capital N is added along with the hyphen mark. Amine is a neutral ligand while nitrito ligand carry a -1 charge. Therefore, the oxidation state of chromium is 3 as the coordination sphere also carry +2 charges. This is why 3, a Roman numeral, is added in a round bracket next to the chromium. Lastly, as the coordination sphere carry a charge, the suffix ion is added after leaving a space. This complex is similar to the previous one. Here the nitrito ligand is bonded to chromium through oxygen atom. So instead of capital N, capital O is added along with the hyphen mark. Rest is the same as the previous one. In this complex, the coordination sphere is an anionic part and carry a uni-negative charge. So we must write the potassium name first. The coordination sphere consists of fluoro and oxo ligand which carry -1 and -2 charges respectively. Alphabetically, fluoro will come first, so tetrafluoro, then oxo. Since chromium atom is a part of an anionic coordination sphere, so it will be written as chromate. The oxidation state of chromium based on the other ionic species is 5. So 5 in the Roman numeral is also added in parenthesis. In the second complex, we have three different ligands: chloro, nitrito, and amine. Alphabetically, amine will first, then chloro, followed by nitrito. Both chloro and nitrito are uni-negative in charge, and the coordination sphere carry a uni-positive charge. Therefore, the oxidation state of cobalt is 3. After leaving a space, iron. So, tetraamine chloro nitrito hyphen N hyphen cobalt 3 space iron. In this complex, we have two coordination sphere. One is cationic and other is anionic. In the cationic coordination sphere, there are 4 amine ligands that are neutral. The cationic coordination sphere carry +2 charges. So, we will write tetraamine copper 2 space. In the anionic coordination sphere, there are 4 chloride ligand. Moreover, the anionic coordination sphere carry 2 minus charges. The oxidation state of copper will be 2. Since cobalt is a part of anionic coordination sphere, it will be written as cuprate 2. So, tetrachlorocuprate 2. Overall, tetraamine copper 2 space tetrachlorocuprate 2. Similarly, the IUPAC nomenclature of the second complex is tetraamine platinum 2 space hexachloroplatinate 4. In this complex, we have ambidentate dithioxylato ligand that has 2 donor side, oxygen and sulfur. This ligand carry 2 negative charge. Also, nickel is a part of an anionic coordination sphere, so its name will be written as nickelate. So, its IUPAC nomenclature is potassium space bis dithioxylato, as there are 2 such ligand, hyphen oxygen comma oxygen hyphen, as both the donor side are oxygen, nickelate 2. These two complexes are also the same, except the bonding site of the ligand involved with the nickel. In the first complex, both the sulfur atom are involved in the bond formation. So, hyphen S comma hyphen is written in the nomenclature, while in the second complex, one sulfur and one oxygen atom are involved. So, hyphen S comma oxygen hyphen is written in the nomenclature. As per the alphabetical order of the ligand, pentaamino sulfato rhodium 3. The perchlorate ion carry a -1 charge, while sulfate carry -2 charge. Thus, the oxidation state of rhodium is 3. So, space perchlorate. So, in this complex, zinc space tetra bromo iodate 3. The oxidation state of bromide and zinc is -1 and +2 respectively. So, the oxidation state of iodate must be 3. So, in this complex, potassium space alphabetically chloride will come first, then nitride. So, pentachloro nitrido, the nitride ligand 3 minus charge. So, 5 minus charges from 5 chloride and 3 minus charges from nitride, overall 8 minus charges, out of which 2 are balanced by the potassium. Therefore, the oxidation state of osmium must be 6. Since it is a part of anionic coordination sphere, so we have to write osmate 6. So, in this complex, lithium space pentacarbonyl manganate, since manganese is a part of an anionic coordination sphere, manganate -1 charge, because lithium carry +1 charge. This complex has 2 ligands, chloride and ethylene diamine, and alphabetically chloride will come first. Ethylene is a polydentate and there are two such ligands. So as mentioned earlier, we use the prefix bis instead of di. So dichloro bis in a bracket ethylene diamine bracket close. The coordination sphere carry unipositive charges and two negative charges from the two chloride. Therefore cobalt must be in the +3 oxidation state, cobalt 3. After leaving a space, we have to put ion. In the cationic coordination sphere, chromium is bonded with 6 neutral amines, while in the anionic coordination sphere, copper is bonded with 5 uninegative cyanide. The charges on the coordination sphere are not mentioned, so these metals exhibit their most stable oxidation state. Thus, the oxidation state of chromium is +3, while the oxidation state of copper is +2. So the nomenclature is hexaamine, chromium 3, space pentacyanocuprate 2. There is a peroxide bridging ligand in this complex. So mu hyphen peroxo hyphen tetra kiss ethylene diamine, as there are 4 ethylene diamine ligands. Dicobalt 3 hydroxide. The charge on the peroxide is -2, while there are 4 hydroxide ions each carrying a -1 charge. To balance this -6 charge, we have 2 cobalt ions, so the oxidation state of cobalt will be +3. In this complex, first we will write the tetramethyl ammonium. Out of 3 negative charges provided by the 3 chloride ion, one is balanced by tetramethyl ammonium. Ethylene is neutral, so platinum carry +2 oxidation state. Also, platinum is a part of an anionic coordination sphere. Its name is written as platinate, platinate 2. So overall, tetramethyl ammonium space trichloroethylene platinate 2. The palladium exhibit two stable oxidation states, which are +2 and +4. In the anionic coordination sphere, there are 3 chloride ions, so the palladium must have a +2 oxidation state to leave a -1 charge on the anionic coordination sphere. Also, there are 2 such anionic coordination spheres, each carrying a -1 charge. Therefore, the oxidation state of palladium in the cationic coordination sphere will be +2. Thus, the nomenclature of this complex is tetra aqua palladium 2 space amine trichloropalladate 2. Out of 4 negative charges provided by the 4 isothiocyanate ions, one is balanced by tetramethyl ammonium. So the oxidation state of chromium is +3. Since chromium is a part of an anionic coordination sphere, its name is written as chromate. So tetramethyl ammonium space amine tetraisothiocyanate chromate 3. This complex possesses 2 bridging ligands, amide and peroxide. So based on the IUPAC rules discussed earlier, its name is mu hyphen amido hyphen mu hyphen peroxido. The charges on the amide, peroxide and phosphate ion are -1, -2 and -3 respectively. To balance these -6 charges, we have 2 cobalt ion. Therefore, the oxidation state of each cobalt will be 3. On either side of the bridging ligand, we have 4 amines and a cobalt. Thus, its IUPAC name can be written as mu hyphen amido hyphen mu hyphen peroxido bis in a bracket tetraamine cobalt 3 space phosphate. This complex also possesses two bridging ligands. So based on the IUPAC rule, mu hyphen hydroxido hyphen mu hyphen nitrito, there are two trichlorostenate ligand on the either side of the bridging ligand. The charges on the hydroxido, nitrito and trichlorostenate ligand are -1. All have same charges. To balance this -6 charges, we have two cobaltine, but the coordination sphere already carry up -4 charges. Therefore, the oxidation state of cobalt will be +1 only. Thus, its IUPAC name will be mu hydroxido hyphen mu hyphen nitrito tetrakis trichlorostenate dicobaltate space ion, since cobalt is a part of an anionic coordination sphere. In this complex, we have potassium. There are two dithiosulfate ligand. So dithiosulfate, potassium space dithiosulfato. Silver is a part of an anionic coordination sphere, so its name will be written as argentate. Each thiosulfate carries two negative charges. Out of total of 4 negative charges, 3 are balanced by 3 potassium ions. Thus, the oxidation state of silver is +1. In the second complex, there are two ligands, imide and amine. So, alphabetically, amine will written first. So, tetraamine, imido carry -2 charges and bromide carry -1 charge. Therefore, the oxidation state of cobalt is +3. Cobalt 3 space bromide. As bromide is outside the coordination sphere, its name remains the same. This complex possesses 3 chloride bridging ligand. So based on the IUPAC rules, potassium space mu hyphen trichloro. Here thallium is a part of an anionic coordination sphere, so its name will be written as thalidate. So bis in a bracket trichlorothalidate 3. Overall, there are 9 negative charges due to 9 chlorides, out of which 3 are balanced by the 3 potassiums. So there are 2 thalliums must balance the remaining 6 negative charge. Therefore, the oxidation state of thallium will be +3. In the second complex, there are 3 ligands. In the second complex, we have a barium space tetrafluoro bromate 3. The oxidation state of fluoride and barium is -1 and +2 respectively. So the oxidation state of bromate must be +3. Here in this complex, we have 3 different type of ligands. So its IUPAC name will be like bromo, bis ethylene diamine, nitrito hyphen O hyphen cobalt 3 ion. Nitrito and bromide carry a -1 charge, while the coordination sphere already carry a +1 charge. So the oxidation state of cobalt is +3. In this complex, all the 4 ligands carry a -1 charge. The oxidation state of platinum is +2. So there will be 2 negative charge on the anionic coordination sphere. To balance these 2 negative charge, the oxidation state of arsenic must be +5. Thus, its IUPAC name is tetraphenyl arsonium 5 space dichlorido hydrido methanido platinate 2. Since platinum is a part of an anionic coordination sphere. Here both the coordination sphere consist of platinum as central metal. The platinum metal present in an anionic coordination sphere must have lower +2 oxidation state, while the platinum metal present in a cationic coordination sphere has a higher +4 oxidation state. Thus its IUPAC name is tetraamine dichlorodo platinum 4 space tetrachlorodo platinate 2. So far we have discussed the naming of the many coordination complexes. Now let us give the chemical formulas of some of the coordination complexes. The first complex is diamine silver 1 space tetrachlorocuprate 2. As the name implies, there are two coordination spheres. First we will write the cationic coordination sphere, diamine silver. Since amine is a neutral ligand, therefore coordination sphere will carry the +1 charge of the silver. So diamine silver +1 charge of the silver. Now come to the anionic coordination sphere, tetrachlorocuprate. Since chloride carries a -1 charge while the copper carries a +2 oxidation state, therefore anionic coordination sphere carries 2 negative charge. Tetrachlorocuprate 2 negative charge. Now balance the coordination sphere using the crisscross method to get the chemical formula. This complex also has two coordination sphere. First we will write the cationic coordination sphere. So hexaamine iron. Since amine is a neutral ligand, therefore the coordination sphere will carry the +2 charge of the iron. Now come to the anionic coordination sphere, hexachlorochromate. Since the chloride carries a -1 charges while chromium has a +3 oxidation state, therefore anionic coordination sphere carry 3 negative charges. Now balance the coordination sphere using the crisscross method to get the chemical formula. This complex has 3 chlorides and 1 ethylene ligand. Platinate, that means platinum is a part of an anionic coordination sphere. Ethylene is a neutral ligand and 3 chloride will give 3 negative charges. The oxidation state of platinum is +2. So anionic coordination sphere will carry -1 charges. There is a potassium outside the coordination sphere that carry +1 charge. Now balance the cationic and anionic part using the crisscross method to get the chemical formula. This complex has 4 fluorides and 1 oxo ligand. Chromates mean chromium is a part of an anionic coordination sphere. Each fluoride and oxo carry -1 and -2 charges respectively. So oxidation state of chromium must be +3. So anionic coordination sphere will carry -3 negative charge. There is a cesium outside the coordination sphere that carry +1 charge. Now balance the cationic and anionic part using the crisscross method to get the chemical formula. In this complex, there is 1 amine ligand, 4 water molecule and chromium in a +2 oxidation state. Both amine and water are neutral ligand, so +2 charges of the metal will be acquired by the coordination sphere itself. And there is a sulfate outside the coordination sphere. Now balance the cationic and anionic part using the crisscross method to get the chemical formula. Here we have 5 cyanide, 1 nitrosyl ligand and ferrate metal. Nitrosyl is a neutral ligand. Cyanide has a -1 charge. Iron is in +2 oxidation state, so the coordination sphere will acquire -3 charges. And there is a potassium outside the coordination sphere. Now balance it using the crisscross method to get the chemical formula. This complex has 8 chloride ions and 2 renate. This means rhenium is a part of an anionic coordination sphere and has +3 oxidation state. Also, the coordination sphere will acquire 2 negative charge, and there is a potassium outside the coordination sphere. Now balance it using crisscross method to get the final chemical formula. This complex has 2 thiosulfate ligand and aurate. Aurate means gold is a part of an anionic coordination sphere and has +2 oxidation state. Also, the coordination sphere will acquire 2 negative charge. There is a sodium outside the coordination sphere. Balance it to get the final chemical formula. This complex has 5 chloride ligand, 1 nitrogen ligand and 1 osmate. Dinitrogen is a neutral and chloride has a -1 charge. Osmium is in +3 oxidation state, so the coordination sphere will acquire 2 negative charges. And there is a potassium outside the coordination sphere. Balance it to get the final chemical formula. This complex has neutral ligand, so tetraaqua, nitrito, dimethylamine, cobalt. Cobalt means the oxidation state of cobalt is 0. This complex has 2 bromides and their charges are balanced by the nickel metal, which is in the +2 oxidation state. So dibromo, bis triphenylphosphine, nickel 2. Here we have 5 cyanides, 1 carbonyl ligand and ferrate metal. Carbonyl is neutral and cyanide has -1 charge. Iron is an +2 oxidation state, so the coordination sphere will acquire 3 negative charge, and there is a potassium outside the coordination sphere. So balance the cationic and anionic part using the crisscross method to get the final product. As the name implies, there are 2 coordination spheres. First we will write the cationic coordination sphere. Diamine silver. Since amine is a neutral ligand and there is a silver metal which carry a +1 oxidation state. So whatever the oxidation state of silver will be carried by the coordination sphere. On the other side, we have an anionic part that contains tetracyanoplatinate. So tetracyanoplatinate, the oxidation state of platinum is 2, while each cyanide carries negative charges. So overall we have 2 negative charges on the anionic coordination sphere. Balance it using crisscross method to get the final chemical formula. Now I end this video here. Thanks for watching. Please like and subscribe to my channel. See you in the next video of this coordination sphere compound series.